So anything that's in an up position from the floor, from the ground, from somewhere, that's the potential we're talking about in gravitational potential energy. So what in this room might have more potential energy than that clock? That's a good starting point. The ceiling. The ceiling. Why do you think the ceiling has more potential energy than the clock?
Because it's higher.
Height's a component, isn't it? Right? As we lift this desk higher and higher and higher and higher and higher, we would give it more potential energy, wouldn't we? Okay, what else? What do you say? The ceiling. Talking about all the ceiling, or just like one tile? You pick the ceiling, girl.
I guess all of it.
Okay, collectively, it's up a little higher than the clock. And what else collectively does all the ceiling have a lot of? Has a lot of mass. This means mass. Okay, that's their sequence, mass. Okay, so what are the components of potential energy? Well, someplace you have a formula, and it says it's the mass of the object times the height. Now, by height, we don't mean how tall you are. We mean how far it's been picked up from the surface. And a third thing called well, that's a mouthful. Free fall acceleration due to gravity. You know the phrase, but you will typically, simply, most people say G. Or G. Times G. Gravity. It really means the free fall acceleration due to gravity. Things fall because gravity pulls them down. Now, there were some formulas. It didn't make it very clear, but every time on planet Earth, G will be equal to 9.8 meters per second squared. That's just a unit. It's a constant. It's like pi. You use pi 3.14 in math class, right? Okay, so it's a constant that the physicists of the world say that is the free fall acceleration due to gravity. You will always plug that in. You will always plug that in. Okay, so grab a calculator. All right, so this is 78 in your folder. I gave you the formula across the top. The mass times the height times the gravity. Just a few key things to make it work. Units are important. These last 17, 18 days, whatever we have together, be a lot of different units. We talk about a lot of different forms of energy. Mass will always be in kilograms. Height will always be in meters. This gravity thing is in meters per second squared. It just is. When you are done, energy is measured in a unit called a joule. Well, it's spelled that way because it's named after scientists. Your final value is end up in being what we call a joule. Okay, first example, modeling is done for you. Let's just punch it in our calculators, make sure our calculators work. So we're going to put in 1.22. We're going to hit the multiplication sign. We're going to punch in 10.25 because that's how high this ball got lifted. We're going to hit the multiplication sign. We're going to punch in 9.8 because that is the free fall acceleration due to gravity. Hit the equal sign and it says 122.549. Anyone get a different answer? Because we had somebody over and over and over get the wrong answer and we decided it was the calculator and we threw that calculator away. All right. Have you ever talked about significant figures?
That sounds familiar.
Have you ever talked about significant figures? Okay, you were here and we did all that, but not the formula. We have I kind of thrown them at you, but you didn't get the whole spiel early here
I'm
either.
not.
Okay, good. So, we need to talk a little bit about significant figures. This is what your calculator said, and if you get that, I am happy. I am happy. However, sometimes your calculator spits out a great big answer and we need a place to round off. Danielle, how many sig figs in this original answer?
3.
All right. Anytime I see a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, or a 9, it is called a significant figure. I see a 1, I see a 2, I see another 2, that's why it's called 3 sig figs. So that had, we got a 0. We got a 0 in the middle, Taylor. Is that a significant? Yep. So 1 is significant, the 2 is, the 5 is, and that 0 that's in between is. That's a 4 sig fig answer. Okay, Miss Candace, how many sig figs in 9.8?
2.
Good answer. Uh-oh. I have a 3 sig fig multiplied by a 4 sig fig multiplied by a 2 sig fig. How many should I keep in my answer? Go with the fewest. Go with the fewest. Go with the fewest. Do that to your paper right now. Scratch that out. Somebody did that. I don't. Some bad teacher did that. We are only allowed 2 significant figures in this answer. All right. The first number is a 1, and it shall stay a 1. The second number, 2, and it's most likely to stay a 2, but we're going to check the third number just in case. That 2 is followed by a 2. So should I keep the first 2 a 2, or should I round it up to a 3? All right, the second number is going to stay a 2. All right, is it likely, if I had $122.549, would I round it off to $12? No, I got robbed. How do I keep the 1 in the hundredths place value? I gotta put a 0 there to hold its place. I gotta put a 0 there to hold its place. So I will round off 122.549 to 120. That looks reasonable. The sig figs. I don't expect you 2 to be sig fig experts yet. I expect you 3 to be sig fig experts. Lucky you guys. All right. So I'm simply saying, if you're getting that number right, I'm happy. I'm happy. I'll talk to you about how this individual YouTube got. Okay, ladies. So if you would go ahead, do 1, 2, 3. I'll be around. I'll be around.
The very bottom one.
Okay, we've all got wonderful numbers. I bet we have things like, let me see here, 20. The jumper, is that the 26?
That's
1,
8.
8, 0, 0. Wow! When she's atop the bar, frozen there in space for a moment, she got over 1,000 joules of potential energy. But that rock, why? Why didn't that rock have so much energy in it? Got a little mass, doesn't it? Has a little mass. So which one higher? Which went higher? All right, all right. Which went higher? How high is the jumper? She's 2.2 meters. How high is the rock? Okay, so read the question. Sometimes your brains think that I'm asking you something different. Oh, who had the most potential energy? Oh, the jumper did, didn't she? Okay, so read the question. So let me just make an analogy here. You know I love my bowling balls over here. I need someone to stand on the table and hold this ball to the ceiling.
I will.
Okay, that's
Can I take my shoes off?
all right, it's up to you. tall. I'll kind of reverse around.
Okay, how high?
You can say hold over my head.
Oh,
Isaac,
my-
don't fall off the back, girl.
I'm not.
Scaring me.
I'm fine.
Okay, put it over your head, will you? Okay.
Don't drop on my foot.
Do you trust me?
Yeah, I'm just.
Okay, trust me. Trust me. I will. Which problem? Don't fall off it, Rick. Don't look. Which probably has more potential energy? But that one's much higher. Okay. Which factor, trick question, which factor is more important? The height or the mass? Trick question. They're both equal, aren't they? They're both in their formula. Okay. So something not very high, can have a lot of potential. Now, the potential is when I'm holding it. When I drop it, that suddenly became kinetic energy. But we're thinking, oh, but I drop it to give you the sense of ouch, that can hurt. Go ahead and drop it on your toe. Drop it too. Yeah, right there. Okay. So that's what I'm trying to get across to number 5. Thank you very much. So she does fine up there, and then she crashes into the ground. Thank you. All right. We feeling pretty good so far about making sense, how they use the formula and all that good stuff? All right, let's kind of speed some things up here. So you're going to need a moment to number 5. I'm sorry, I'm rushing.